Hi everyone, welcome to this video where today we are talking about systems of equations, and so we're going to do a complete review on graphing, substitution, elimination. All right, right off the bat, first one, it says what is the solution to this system? We need to remember that when you have equations of lines that are parallel to each other, third grade, right? Parallel lines never intersect. So if I see a set of parallel lines, immediately I know there's no solution. The intersection is where the solution is. Parallel lines don't intersect, so simply no solution. Now, if I tell you that there's actually a system of equations in this problem and you only see one line, that means that the lines aren't parallel, they're not intersecting, they're actually equations for the exact same line. They are overlapping each other. So every single point on one line matches up with every single point on the other line, and that's what we call infinitely many solutions. Now, it says here, the following system has how many solutions? And I have two equations. I have x plus y equals 3, and I have x plus y equals 6. Now, one thing I can do is I can put them in slope-intercept form. Maybe that'll help me. Like this first equation here, if I write it in slope-intercept form, would look like y equals, whoops, there we go. It would look like y equals, if I subtract my x, it would look like y equals negative x plus 3. And then the second equation, if I write that in slope-intercept form as well and I subtract my x, it would look like y equals negative x plus 6. Now what I should notice is that those equations have the exact same slope of -1. They have different y-intercepts. So I know before I even graph anything like that, that they are certainly going to be parallel lines. Parallel lines never intersect, so there's no solution. Whereas in number 4, if I take a look at problem number 4 is y equals negative x plus 3. So y equals negative x plus 3. And y equals 4x minus 5. Now, I know that they're not going to be infinitely many, because if they were the same exact line, it would be infinitely many. I also know that those two lines are not going to be parallel because they don't have the same slope. So what's left? It's not infinitely many. It's not no solution. These lines would definitely be intersecting. I'd have a -1 slope, a +4 slope. Eventually those point lines are going to intersect each other, and so there's going to simply be one solution. Number 5, same idea. Y equals 2x minus 3, y equals 2x. So y equals 2x minus 3, and y equals 2x. Not the same exact line. This has a y-intercept of -3. The second one has a slope y-intercept of 0. I do know that they're going to be parallel. Sorry. I do know that they're going to be parallel because they have the same slope. So again, parallel lines, they never intersect each other, and so it's going to be no solution. Last one of this skill, ready? 2x plus y equals 6, and y equals -2x plus 6. Now, they're not in the same form. I noticed the first equation's in standard form, the second equation's in slope-intercept form. If I was to rewrite that second equation in slope-intercept form, it would look like y equals, I would have to subtract my 2x, so minus 2x and then plus 6. And what I'm going to notice is that that equation is identical, same exact line, two equations for the exact same line, and so I would know that my solution is infinitely many. Now, solving, actually getting some answers here by substitution. That's our first skill. So ready? First equation says y equals 3x plus 2. Second equation is 2x plus y equals -8. In substitution, we want one or both equations to be set equal to a variable. So here, I notice the first equation is already y equals. Y is equal to 3x plus 2. So this means where I see a y in my other equation, I'm going to replace that with 3x plus 2. So now my second equation is going to look like 2x plus, not y, but everything that y is equal to, which is 3x plus 2, and then I just bring down the rest of my equation, -8. I do my regular solving equation skills here. And I end up getting that x equals -2. And that's wonderful. And I can already see that there's two answer choices there that do have an x value of -2. However, the solution to a system, if there is a solution, is an ordered pair. Once I have x, I do need to then solve for y. I can technically choose either one of these blue equations. If I'm going to solve for y, though, the easiest thing is to actually choose the equation that's already in y equals form. So if I grab y equals 3x plus 2 and I do y equals 3, I'm actually going to plug in that negative 2 for x, and then I'm going to simplify it. 3 times negative 2 is negative 6, and negative 6 plus 2 is negative 4. And so my solution is my x comma value, then y value. And there you have it, negative 2, negative 4. Number 8, use substitution. So again, and this is a nice system because notice that both equations are actually set equal to y. And so if y is equal to negative 4x plus 1, then where I see y in my other equation, that's what I'm going to plug in. So instead of y equals x minus 5, it's going to say negative 4x plus 1 equals x minus 5. Notice I only have x in my equation, so now I can solve for it. I'm going to use just my regular good solving equation skills that we did earlier in the school year. Oops. Add 5. 6 equals 5x, divide by 5. Oops, running out of space. And I end up getting x equals 1.2. Now I do notice there's only one solution with 1.2, so I should be on the right track. To solve for y, I can grab either y equals equation. It does not matter. I think I like the second one better. So I'm going to choose y equals, I'm going to plug in my x value of 1.2 minus 5. 1.2 minus 5 is negative 3.8. And so my solution is 1.2, comma 3.8. Oh, negative 3.8. Excellent. Number 9, same thing, substitution. 2x minus 3y equals 6, and I have x plus y equals negative 2. Now, the problem right off the bat here is neither of these equations are x equals or y equals. And so you are allowed to, in mathematics, like manipulate equations to make them be in the order and function that you want them to be. So, and you could be selective, right? I see the first equation, 2x minus 3y equals 6. I could get x or y by itself, but it's not going to be as clean as maybe looking at the second equation. Like, notice the second equation, it's going to be really easy to get x by itself. Or it's going to be very easy to get y by itself. And it really wouldn't matter which one you do at all. I'm going to choose to get y by itself just because I like y equals, which means I'm going to go ahead and subtract x on both sides. So this would then become negative x minus 2. Since y is equal to negative x minus 2, I'm going to plug that in carefully where y is in my other equation. So now that becomes 2x minus 3, not times y, but times everything that y is equal to. And I'm then just going to go ahead and solve. Negative 3 times negative x is positive 3x. Negative 3 times negative 2 is positive 6 equals 6. I end up getting 5x plus 6 equals 6. Subtract 6 on both sides. You actually get 5x equals 0. I don't want you to think you did anything wrong here. If you divide both sides by 5, you get literally x equals 0. 0 is totally an answer for x and y. Sometimes students think they're doing something wrong. Once I have my x, I need to find my y. I'm going to use this beautiful y equals equation. So y equals negative 0, right? I'm plugging in my answer for x, which is 0. And I end up getting y equals negative 2. And so my solution is 0, negative 2. Elimination practice now. Elimination practice. So elimination is a very good skill for solving a system. Graphing is a strategy for solving. Substitution is a strategy for solving. But elimination works out so nicely when you have two equations that are in standard form, and when you stack them, you can clearly see that you have opposite coefficients of one of the variables. Here, x and x, same coefficient, positive 1. But y and negative y, that's a positive 1 coefficient and a negative 1 coefficient. And when you have those opposites and you add these equations together, x plus x is 2x. Positive y plus a negative y eliminates out, completely simplifies out. And then 5 plus 7 is 12. Divide by 2, and look how clean this is. I end up getting x equals 6. after I solve for x, I do need to solve for y. It does not matter which equation you choose. I think I'm going to use the happy one up top with a positive. So x plus y equals 5. So 6, which is my x, plus y equals 5. And if I subtract 6 on both sides, I end up getting y equals -1. And so my solution is 6, -1. See how easy that was? Number 11, same skill. Ready? 2x plus 3y equals 2, and x minus 3y equals 10. My x coefficients are not opposites, 2 and 1, but my y coefficients, again, are opposites. So when I add those up, 2x plus x is 3x, but 3y plus a -3y eliminates out. 2 plus 10 is 12. And again, look how clean this actually is. I end up getting x equals 4. Once you solve for x, you do need to go back and solve for y. It does not matter which equation you choose. Maybe I'll take the second one this time. So if x is 4 minus 3y equals 10, I would have to subtract 4, get -3y equals 6. 6 divided by -3 ends up being y equals -2. And so my solution is 4, -2. Beautiful. Now, in number 12, there are times when we want to use elimination, but the coefficients are not opposites. Okay? And in this case, you can see not only are they not opposites, but man, they are not even the same number, 1 and 3, and then -5, -2, right? So you are allowed, like I said before, to manipulate equations. You can multiply things, add things, however you want to equations to build it in the way you want it to be. So when I look at this system, I look at it and go, man, what do I wish that x was, this up here, right? What would eliminate out beautifully with a 3x? Well, what's the opposite of 3? -3. Man, if that top equation had a -3x, it would just beautifully eliminate out. Well, good news, you are allowed to, whoops, sorry about my screen. You are allowed to multiply that top equation by that -3 to purposely design an equation that becomes this, -3x, -3 times -5y is positive 15y, equals -3 times -10, positive 30. You are allowed to multiply that equation by -3 and then stack that over the original second equation, and now I can beautifully do my elimination. I can add these two equations together. Let me move this over, it's getting a little wonky. I can add these equations together. -3x plus 3x eliminates out. 15y plus a -2y is 13y. And then 30 plus a -4 is 26. Divide both sides by 13, and I get y equals 2. Once I know what y is, I then need to go back and solve for x. Now, you can either use one of the two original blue equations or that new purple equation. It will not matter. I'll grab the second equation here. So 3x minus 2 times my y coordinate of 2 equals -4. So now this becomes 3x minus 4 equals -4. Add 4 on both sides. I end up getting 3x equals 0, which again, totally fine. It's completely fine to get an x or y value of 0, and there's my solution, 0, 2. Number 13, which method listed would be best to solve the system? Now, there can be arguments for this totally. I mean, based on that system, you could technically use any strategy, right? When I look at these two equations here, x plus y equals 4, and x minus y equals 2, and I ask you, what method do you think is best? If you are really good at graphing in standard form, which I love graphing in standard form. I find it to be so easy to find those intercepts. Just do the cover-up method, you're good. Graphing might be for you. Elimination with multiplication, do you really need to multiply either one of those equations by something? Probably not. Substitution, you would just have a little extra work. You have to get one of the equations to have a variable by itself. Or elimination with addition. Probably elimination with addition is very friendly here because those y's are going to eliminate out so quickly. But you could easily make an argument for any of these it would just take a little work. Which one might be the quickest to do? Probably the elimination with addition, where I don't even have to graph everything to see where they intersect. I could just add these two equations up together and have that part be eliminated. How about number 14? Y equals 2x minus 1 and y equals negative 3x minus 4. Now notice these are both in slope-intercept form, and not a single problem I did in elimination had them in slope-intercept form. They were all standard form. So when I look at these two equations, I might say, oh, well, when they're both y equals, that's so easy. You just plug one equation into the other, right? So substitution would be really easy to do here. Or, because they're both in slope-intercept form, and we've been graphing for a few years now, I could probably also graph them pretty easily. So probably substitution or graphing. Number 15, which method listed would be best? So 2x plus 6y equals negative 5, and x equals 5y minus 3. Now immediately the red flag is the second equation. Not in standard form, not in slope-intercept form. We don't graph things in x equals form. This really does look like it's perfect for substitution, right? Everything that x is equal to would get substituted in for x in the other equation. So I think we would probably agree that it's substitution. Number 16, set up a system of equations and find the solution. It says the sum of two numbers is negative 5. So x plus y equals negative 5. And their difference means to subtract, so x minus y equals 7. I need to solve this, and it doesn't say to solve by graphing, substitution, elimination. I could do whatever I want. And when I look at this immediately, I'm like, this is elimination. This is so simple, because if I add them up, x plus x is 2x, y plus negative y, eliminated. Negative 5 plus 7 is 2. Divide both sides by 2, I get x equals 1. And if I know x equals 1, I can substitute that back into either equation. I'm going to use the first one. So then 1 plus y equals negative 5. And if I subtract 1 on both sides, I end up getting y equals negative 6. And so my solution is 1, negative 6. Beautiful. Number 17. Hamburgers are $3 and hot dogs are $2. If you have $30 to spend and you need to buy 12 food items, how many of each can you buy? Okay, so we're going to call hamburgers X, and we'll call hot dogs Y, right? We're trying to find out how many hamburgers, how many hot dogs do we need to buy to meet these two conditions. Okay, now notice there's 4 numbers in the problem. 3 of those numbers are about money. Money stays together. Money stays together. So if I want to write my equation about money, it would be $3 per hamburger plus $2 per hot dog equals, what's my dollar amount that I want that to equal? $30. The second equation is about how many items. It says you need to buy 12 food items. So how many X hamburgers plus how many Y hot dogs do I need? So it adds up to get 12. So now that I have this, I mean, I can solve this in any way that I want. I can use elimination, I can use substitution. It will not matter. Maybe I want to use substitution just because the last problem I did elimination with. So let's say I did rewrite my second equation as y equals negative x plus 12. Again, you can do this a different method and then check with me at the end and see if you got the same answer. Plug it in for y in the other equation, so 3x plus 2 times negative x plus 12 equals 30. I do my regular solving equation skills, minus 2x plus 24 equals 30. 3x minus 2x is x. X plus 24 equals 30. Subtract 24, and I end up getting x equals 6. Great. Once I have my x, I then need to solve for y. I always like to choose my y equals equation if I have it. So y equals negative, my x is 6 plus 12, and negative 6 plus 12 is 6. So that's funny, I need to buy 6 hamburgers and exactly 6 hot dogs for it to work out. Now, the other combinations do add up to 12, but if you plug those numbers in and you do $3 for every hamburger and $2 for every hot dog, it will not exactly equal 30, but 6 will. Number 18, use elimination to solve the system. All right, so 2x plus 6y equals negative 5, and 3x minus y equals 2, negative 2. Okay, my x's aren't going to eliminate out nicely, 2x and 3x, 6y. What would eliminate out with a 6y? A negative 6y, and it's already a negative y, so let me go ahead and multiply the second equation purposely by a 6. If I do that, my first equation is going to stay put. 2x plus 6y equals negative 5. My second equation then becomes 6 times 3x is 18x. 6 times negative y is negative 6y. And then 6 times negative 2 is negative 12. Now, if I do that on purpose, look how beautiful this is going to turn out. So I end up getting 2x plus 18x is 20x. 6y plus a negative 6y eliminates out. Negative 5 minus 12 is negative 17. I do need to then divide both sides by 20. And I do get a decimal here. You could leave it as a fraction, but it's negative 0.85. Okay, now that I have my x, I now need to solve for y. So I'm going to grab maybe my second equation here. So this is now 3 times negative 0.85 minus y equals negative 2. 3.85, so 3 times 0.85. So that would be negative 2.55 minus y equals negative 2. I would have to add 2.55 on both sides. Okay, so I end up getting negative y equals 0.55, and if I divide both sides by negative 1, I end up getting y equals negative 0.55, and that's my solution. Negative 0.85, negative 0.55. Number 19. All right, 3x minus 4y equals 12, and 5x minus 6y equals 20. Man, you can tell right off the bat, right? Like something's not right here. A 3x would eliminate out with a negative 3x. I'm not turning a 5x into a negative 3x. A 5x would eliminate out with a negative 5x. I'm not turning a 3 into a negative 5. So immediately I notice that my coefficients for my x's and y's, they're not as clean as I want them to be. You do have options. You can multiply things by whatever you want to make it work out beautifully. Maybe I want my y's to be opposites. So I look at my 4 and my 6, right? Negative 4, negative 6. What can I turn a 4 and a 6 into? What's a common multiple? Then I can have them purposely be opposites, 4 and 6, 4 and 6. 12. Okay, what if I multiply the first equation? Whoops. What if I multiply my first equation by a 3? So that, let me move my screen. So that I get that to become 9x minus 12y equals 36. What would eliminate out with a negative 12? A positive 12. What would I have to multiply a negative 6 by in order to get a positive 12? It's a negative 2. So if I do that, I end up getting negative 10x. Negative 2 times negative y is positive 12y, that's what I want. And then negative 2 times 20 is negative 40. Now this is just one of the many ways I could have done this problem. You just have to make them opposites. So now I add them up. 9x plus negative 10x is negative 1x. Negative 12y plus 12y eliminates out. 36 plus a negative 40 is negative 4. And if I divide both sides by negative 1, I get x equals 4. I'm then going to go ahead and find my y value. Okay, so to find my y value, let me make my pen just a little bit bigger. I can choose any equation that I want. Maybe I'll choose the second equation just because it's there. So now 5 times 4 minus 6y equals 20. 5 times 4 is 20. I hope you see that every time you end up having the same constants on both sides and you get rid of them, we're always at 0. Right? Negative 6y equals 0, and if I divide by negative 6, I get y equals 0, and so my solution is 4, 0, 4, 0. Last one, number 20, same idea. 2x minus 7y equals negative 15, and then 3x plus 2y equals 12. I notice that my coefficients are not the same, they're not opposites and they're not the same. 2 and 3. Maybe I'll get rid of my x's. What is the least common multiple of 2 and 3? 6. So if I multiply the first equation by 3, I would get 6x minus 21y equals negative 45. Well, what eliminates out with a 6? a negative 6. What would I have to multiply the second equation by to become a negative 6? It would be negative 2. So if I multiply everything in that second equation by negative 2, I get negative 6x minus 4y equals negative 24. I can then go ahead, add these up. X's are gone. This becomes negative 25y equals negative 69. I do see I have fractions here, or decimals. No big deal. So I'm going to do 69 divided by 25. I get y equals 2.76, which I notice there's only one value that even has that. And now I'm going to go back to solve for x. I can choose any equation. I'm going to choose this one. So 3x plus 2 times 2.76 equals 12. This ends up becoming 3x plus 5.52 equals 12. 3x equals, right? I'm going to do 12 minus that 5.52. Oops. I get 6.48, and if I divide both sides by 3, I end up getting x equals 2.16. And there's my solution, 2.16, 2.76. I hope this was helpful. Good luck on your test. Bye.